How do you guarantee that every user on your network is exactly who they claim to be? In this lesson, you will learn how. Welcome back to the Cybersecurity Masterclass, where we transition from the theoretical concepts of zero trust into rigorous architectural deployment. In our previous lesson, we established that the traditional corporate firewall is a dangerous illusion built on the catastrophic flaw of implicit trust. We proved that granting a user unrestricted lateral movement across your network simply because they possess a password is an existential corporate vulnerability. In this specific module, we architect the solution by constructing the three foundational pillars of modern defense: identity management, multi-factor authentication, and micro-segmentation. The absolute core of any zero-trust architecture is a robust, centralized identity and access management system, commonly referred to as IAM. In a legacy environment, identity was often fragmented across dozens of isolated databases, making consistent security audits mathematically and operationally impossible. A modern IAM framework consolidates every single digital identity within your enterprise into a single, highly secure, and rigorously monitored cryptographic directory. Crucially, this directory must govern not only your human employees but also the thousands of automated service accounts and APIs operating autonomously. In the modern cloud ecosystem, a compromised machine identity or API key can cause significantly more financial damage than a compromised human user. However, centralizing identity is completely useless if the mechanism used to verify that identity is inherently vulnerable to rudimentary social engineering attacks. This brings us to the second architectural pillar, the mandatory, uncompromising implementation of multi-factor authentication across all corporate digital touchpoints. As technical leaders, you must accept the mathematical reality that the traditional password, regardless of its length or complexity, is fundamentally broken. Cybercriminals no longer waste computational resources brute forcing complex passwords. They simply steal them through sophisticated phishing campaigns or purchase them on the dark web. To neutralize this threat, your MFA architecture must require at least two distinct verification factors before granting access to any corporate database. These factors include something the user knows, like a PIN, something the user has, like a cryptographic hardware token, or something the user is. Furthermore, you must aggressively transition your enterprise away from legacy MFA methods, such as SMS text messages, which are highly susceptible to interception. Your architecture must demand phishing-resistant authentication protocols, utilizing biometric verification or advanced FIDO to hardware keys for all critical infrastructure access. But verifying the identity of the user is only half of the zero trust equation. We must also verify the integrity of their hardware. If a perfectly authenticated user attempts to access your corporate network using a personal laptop infected with sophisticated keylogging malware, the breach is inevitable. Therefore, your IAM system must dynamically integrate with your endpoint detection and response tools to calculate a real-time device health score. Before granting access, the system must autonomously verify that the device's operating system is fully patched and the corporate antivirus is actively running. If the device fails this instantaneous cryptographic health check, the architecture must automatically deny the connection, regardless of the user's executive rank. Once identity and device integrity are mathematically verified, we arrive at the third and most complex pillar of modern defense: micro-segmentation. In a legacy network, once an attacker bypassed the perimeter firewall, they possess the freedom to move laterally and access any internal server. Micro-segmentation destroys this capability by dividing your overarching corporate network into hundreds of isolated, highly restricted, and independently secure digital zones. Think of this architectural strategy like the watertight bulkheads built into the hull of a modern, highly advanced military submarine. If one specific compartment is breached and begins flooding, the bulkheads automatically seal, containing the catastrophic damage and saving the entire vessel. In a micro-segmented enterprise architecture, every individual cloud workload, application, and database is surrounded by its own dedicated software-defined security perimeter. If a sophisticated ransomware payload successfully compromises an employee's workstation in the marketing department, the infection is mathematically contained within that specific microsegment. The malicious code is physically and logically blocked from moving laterally across the network to encrypt your highly sensitive customer financial databases. Implementing this level of granular network control requires deploying advanced firewalls and routing protocols directly at the hypervisor or cloud workload level. It requires your security engineering teams to possess an intimate, highly accurate understanding of exactly how data flows between your internal corporate applications. You cannot effectively segment a digital network if you do not understand the legitimate, daily communication pathways required to keep the business operational. This is precisely why we mandated the execution of rigorous process mining in the Digital Transformation Masterclass before initiating any cloud migration strategy. The objective mapping of your corporate workflows provides the exact architectural blueprint required to design highly secure, operationally efficient micro-segmentation policies. The ultimate challenge for any chief information security officer is balancing these rigorous, uncompromising security controls with a frictionless daily user experience. If your security architecture is so overwhelmingly complex that it severely degrades operational speed, your employees will actively find dangerous workarounds to bypass it. To solve this, you must integrate your EAM and MFA frameworks with a secure single sign-on protocol combined with continuous, invisible background verification. The user authenticates securely once at the beginning of their shift, and the zero-trust architecture continuously monitors their contextual behavior in the background. If their location suddenly changes or they attempt to download massive volumes of restricted data, the system instantly demands cryptographic ray authentication. This dynamic, risk-based approach ensures maximum enterprise security without hindering the operational agility required to compete in the modern global marketplace. Building this architecture of defense is not an optional IT upgrade. It is a mandatory prerequisite for institutional survival in the digital age. As we transition toward autonomous AI workforces and complex API integrations, the attack surface of your enterprise is expanding at an exponential rate. You must abandon the illusion of the secure perimeter and construct a highly resilient, mathematically verified digital fortress from the inside out. To assist your security engineering teams in executing this complex architectural deployment safely, I have published a comprehensive zero-trust technical guide. This companion documentation details the specific cryptographic protocols required for phishing-resistant MFA and the exact routing logic needed for effective cloud micro-segmentation. It provides robust architectural blueprints for consolidating fragmented legacy directories into a unified, highly secure identity and access management framework. It also outlines the necessary change management strategies to smoothly transition your global workforce to these advanced security controls without causing operational panic. You can access this critical operational documentation immediately in the professional GitHub repository linked directly in the video description below. I strongly encourage you to review these architectural diagrams with your network engineering leads to perfectly align your corporate defense strategy. Building a truly resilient digital enterprise requires a rigorous commitment to understanding the underlying mechanics of identity verification and segmented data flow. Master the discipline of identity and access management, and you will close the primary vector utilized in over 80% of modern cyberattacks. Execute a disciplined micro-segmentation strategy, and you will transform a potentially catastrophic enterprise breach into a minor, easily contained IT incident. The organizations that successfully deploy this architecture of defense today will operate with unparalleled confidence and agility in the global markets of tomorrow. In our next cybersecurity lesson, we will examine the critical concept of least privilege and how to mathematically restrict access to high-value targets. We will define the specific frameworks required to ensure that both human operators and autonomous AI agents only access what they absolutely need. Prepare your infrastructure for continuous verification, but remain fiercely analytical about the objective reality of your current legacy network vulnerabilities. The digital vanguard belongs to those who architect resilient defense based on undeniable mathematical verification, not outdated corporate assumptions of implicit trust. Subscribe to continue the cybersecurity masterclass, download the GitHub Architecture of Defense framework below, and join the vanguard. Thank you for your time.